For thousands of years, humans have used pottery as a method to transport, store, and even boil water. It was the Chinese who over 1,000 years ago first used ceramics to filter water and remove pathogens and sediments. The renaissance of local ceramic water filters has been promoted by a group called Potters for Peace, who since the early 1990s has promoted appropriate ceramic water filtration. The design we'll be talking about today in this video is shaped like a flower pot and was originally made by hand on a potter's wheel in Central America. The ceramic filter is very effective against microbial contamination and improves turbidity, but it should be noted that the filter does not remove chemical contaminants such as arsenic, fluoride, or nitrate. Over the last few years, other organizations such as Resource Development International have made new innovations in the production of this ancient technology. How ceramic water filters work. Ceramic water filters work by two separate mechanisms. The first mechanism is a mechanical one, which is called straining effect. The filter has very small holes called pores, which physically limit what is allowed to pass through the filter. Pore size has been measured in a ceramic water pot using scanning electron microscope. Pore size was found to be in the range of 0.6 microns up to 3 microns. The second mechanism used by a ceramic water pot is a chemical one. Silver, which has been known to be a biocide for centuries, is impregnated into the body of the ceramic filter. As water containing pathogens migrates past the silver, if sufficient contact time occurs, the pathogens will be killed off. The silver also prevents bacteria from growing within the body of the ceramic filter. The silver is not consumed by this process and therefore is not a limiting factor in the lifespan of the filter. How are filters made? Clay of reasonable quality is gathered from natural deposits, usually located near the factory. Oftentimes, the clay comes from a local brick factory. At the RDI factory, unfired bricks are used which have already been extruded and aged. This improves the quality of the clay. The unfired bricks are easy to transport and store at the factory. The bricks are normally sun-dried and then put into a hammer mill, where they are ground to a powder. Rice husks make up the other key component in ceramic filter production. The rice husks are referred to as the burnout material because when heated in the kiln, they're burned up. Other burnout materials have been used by different groups. These include sawdust, coffee hulls, and recycled paper. But in Cambodia, rice husks are abundant and cheap. Rice husks are also put into a hammer mill and made into a uniform size. The hammer mill process can be done at a local miller or at the factory itself. Once you have prepared the starting material, they are weighed out and put into an automated mixer. The mixture of rice husk is 20%, while the remaining 80% is of clay. The dry materials are allowed to mix for 10 minutes to ensure consistency. After 10 minutes, an exact volume of water is added automatically. The wet materials are mixed for an additional 10 minutes. The automated mixing system is controlled by a simple timing device to ensure the quality of the filters remains constant. Any time after the 10 minutes, the resulting clay mixture is ready to be put into the press. The operators remove the clay and weigh out approximately 8.2 kilograms. The clay is kneaded into a standard shape and then placed inside the hydraulic press. The clay is pressed by the mold into the pot shape and is removed from the mold by 3 ejection pins. The filters are carefully removed from the press and they are placed on the floor in a drying area to begin hardening. The filters are left undisturbed in the hardening area for several hours. At this point, workers shape up the filters and use simple punches to press in the manufacturing date, manufacturer's name, as well as a special number. This information can be put into a database to allow tracking of the filter throughout its lifespan. Filters remain in the hardening area until the next day, when they are loaded onto drying racks. A jack dolly is then used to move them out to a drying pad. The racks are color-coded, which allows the factory to easily track the filters throughout the process. Filter drying times vary depending upon the weather conditions. Once the filters are dry enough, they are carefully loaded into the kilns. The filters are stacked inside the kilns in a special way to ensure there's even and thorough heat passing through them. 2 pyrometric cones are used inside the kiln to monitor the temperature. The kilns are heated to approximately 100 degrees Celsius for about 1 hour to drive off any excess water. Then the heat is gradually increased until the temperature reaches about 866 degrees Celsius. The first pyrometric cone melts at approximately 830 degrees Celsius. This alerts the person firing the kiln to begin monitoring the temperature very closely. Once the second cone begins to melt, the fuel is removed from the kiln and the damper doors are placed over the entryway of the firebox. The entire firing process takes about 9 hours. The kiln is then allowed to gradually cool for a minimum of 24 hours. The filters are carefully removed and placed back on their color-coded racks. The filters are then rolled up to a soak tank. Filters are soaked in the tank for a minimum of 3 hours. Then they're placed on the flow testing racks. The filters are filled to the brim and a timer is started. At the end of 1 hour, a special T measuring device is used to determine the flow rate. If filters have a flow rate outside of tolerance, they are immediately removed from the process. High quality control is essential to the future of the filters. Filters that pass the flow rate test are dried and then taken over to an area to be treated with a silver solution.